All right, everybody, let's go over these absolute value functions because on your quiz today, on your quiz tomorrow, you will encounter some of these on your quiz tomorrow, at least one. So, can someone please describe the first equation? What does the first equation look like? Brian.
Well, I have a question.
Oh, yeah, what's up?
Okay, so like, you know how you said these will be in the quiz tomorrow?
Yeah.
Would it make a graph, like a chart still?
No, you will not have to. In fact, I would highly discourage you from making a chart. I just want you to kind of, like, you will get this graph. So, and on some level, it has to be a little bit accurate, but you'll get this, and you just have to show me that you know what a vertical or a horizontal shift looks like, or whether it's flipped or growing twice as fast, whatnot. Okay? So, what does this look like then? Anyone know? Jessica Bradshaw. It's going to be to the right 3, opposite of your intuition, right? And it's a V like that. Whoopsie. If you basically give me this on your quiz tomorrow, full credit. All right? What about number 2? Who can describe the change in number 2? How is number 2 graphed? Amol.
It's like a regular graph, but the vertex is going to be 3 places on the y-axis.
3 places up on the y-axis, right? And that's it. Okay, number 3. Who can raise their hand? Couple of a couple of things happening. Joshua, sing that song for me.
Wouldn't it be 4 to the right and 2 down?
4 to the right and 2 down. I like that, Joshua. You got that song, the one that I like so much? Yeah. All right. Anyway, number 4. Who can describe number 4? Mr. President, how about number 4 for us? Okay. -2 up 1, and it's upside down. Raise your hands if you're 4 for 4 so far. You got 4 correct. Good. Should be a piece of cake with this one. Oops, and we're out. Okay. Number 5. How about... Let's see. Robert, can you describe number 5, please?
3 to the left and then 3 down.
Uh-huh. Regular graph, right? Number 6 should be, I'll take on number 6. Number 6 is to the right 4, right?
No.
To the right 4 and up 1? No, where is it?
To the left.
To the left 4 and up 1. And then it's what, Aaron?
It's inverted.
Inverted, upside down. Boom. Okay. Who can describe this graph here? How about Max? Ouch! Bamboo shoots in my fingernails. To the right 1. Skinnier than normal. Good. Number 8. Amrit.
It's 3 to the right.
Uh-huh.
3 down and
Twice as skinny. So, 3 times as skinny versus twice as skinny. I'm not going to ding you much on it. But, just understand that it's skinnier. Raise your hands if you got all 8 correct. Good. Good, good, good. So yesterday, with solving systems, we learned a very inefficient method called graphing, and it's inefficient for a number of reasons. One, I can't draw straight to save my own life, and I don't think anybody with, with an unsteady hand could. But we have other ways of solving algebraically, and yesterday someone even asked, isn't there a way we can just kind of use like elimination or substitution? It's like, yes, you can, but no, you couldn't do that yesterday because technically you don't know it yet in this class. So it's time to learn it so you guys can employ it. Substitution, there are 2 methods in solving systems algebraically. There's substitution. Actually, I'm going to type this out instead. There's substitution, which is used best when a variable is by itself or easy to get by itself. Does that make sense? When a variable is by itself or easy to get by itself? Let me show you guys an example of what I'm talking about here. Example 1 is going to be n equals 3m plus 7. And then the second equation is 4m plus 9n equals 1. Now, remember, keep your eye on the prize. The reason why we are doing this is because at some point, both of these lines are going to intersect each other, and when they intersect each other, both equations will be equal. Because n is already by itself, because n is already by itself, does it make sense that I can take this equation here and plug it into n? Does that make sense? Okay, good. So what that looks like is 4m plus 9 times 3m plus 7 equals 1. And now I go ahead and solve for m. Distribute 27m plus 63. 4m plus that equals 1. I'm going to combine my like terms. 27 plus this thing is 31. 31m plus 63 equals 1. 31m equals negative 62. M equals negative 2. Now remember, that is only one coordinate in my coordinate plane. I've solved for m, and now I need to solve for n. So, who can raise their hand and tell us which, or rather, decide which one is easier to plug into? Which one is easier to plug into? Lucas. The first one. Let's plug it into the first one. N is going to equal 3 times negative 2 plus 7. So I get n equals negative 6 plus 7, and n equals 1. Raise your hands if you got to that answer before I did. Before me? You can beat me to it? Good. Okay. I'm going to give you guys 2 more to do on your own. Substitution is pretty simple. It's elimination that I really want to focus our efforts on. Joshua, how you doing? You can access any level in Krusty Super Funhouse, can't you? Do you guys know that? Have you guys ever seen this game called Krusty Super Funhouse for the Super Nintendo? You want to know what the secret password is to get into any level? Joshua. You type Joshua at the very beginning, and you can and Krusty the Clown can get access to any level he wants, and you beat the game. Yeah. Anyway, go ahead, start. Okay, if I plug x into here, what I get is I get 3 times negative 3y plus 13. Sorry, I'm having a rough day. 9y minus 39 plus 2y equals 27. 11y, right? Combine these two. Equals, what's 27 plus 39? What do we got here? Aaron? 66? I like that. That works. Y equals 6. Raise your hands if you got y equals 6 as your first part of the answer. Excellent. Let's see here. Evan, which one do you want to plug it into? Top one? I like that. X equals negative 3, parentheses 6 plus 13. X equals, this is negative 18, so I get negative 5. Raise your hands if you got negative 5, 6 as your answer. Good, good, good. Okay, next one here. Take y, pump it into here, I get x minus 2 times negative x plus 4 equals 1. Pump that in, x plus 2x minus 8 equals 1. 3x minus 8 equals 1. 3x equals 9. X equals 3. Raise your hands if x equaled 3 on your paper. Does x equal 3? Excellent. Let's see. Kiyomi, what do you want? Top one? Sure. Y equals negative 3 plus 4. Y equals 1. Raise your hands if 3, 1 was your answer. Good job. Scale of 1 to 3, 1 being easy, 3 being hard. Where are you with this stuff? Good. Lots of 1s. Don't worry, Joshua, I'm not going to make a Krusty the Clown joke or anything at you. Okay, the next one is elimination. And elimination is good, or best, when both equations are in standard form. And again, this is stuff that you guys probably have seen before. In fact, definitely have seen before. We're just going to kind of rehash it a little bit. If I say example 1, whoops, I'm on the opposite side. If I say example 1 here is m plus n equals 6 and m minus n equals 5, what I'm going to do with elimination is I'm going to add downward. So if I do m plus m, I get 2m. N minus n plus negative n goes away, and that's the objective. You're trying to eliminate one of the variables, right? You're trying to eliminate. And then 6 plus 5 is 11. So I divide both by 2. M equals 11 over 2. Or if you really, really desire, 5.5. Pump that thing back into one of those. I'll choose the top, so I go 11 over 2 plus n equals... Now, hang on for a second. I'm going to have to subtract 11 over 2, right? So instead of writing 6, what number should I write down as it equaling? Instead of writing down 6, what should I write down as the answer? Jessica? 12 over 2. Raise your hands if that lost you. No? Okay. N equals 1/2. Yeah? Good? Amol? Hey, Jared.
How did you do that last part?
12 over 2?
Yeah.
Okay, so remember, what it is it's 11 over 2, you good with that? Plus n equals 6, right? But you know that I'm going to have to subtract 11 over 2 to solve for n, right? So what I did was I did the common denominator bit in my head. Yeah, so 6 minus 11 over 2, that is 12 over 2 minus 11 over 2. And we just kind of bypassed all of this stuff. Cool. Good question. That tends to be a bit of a whoa maneuver for everyone. Everyone's like, oh gosh, what did he just do? No problem. Can I give you guys this one to do on your own? Negative 4a plus b equals negative 26. 8a minus b equals 54. Did someone say no? Did someone say no? All right, let's do this here. Bam, that goes away. 4a equals 54 minus 26? 28, yes. Yes. A equals 7. Raise your hands if you got a equals 7. Excellent. Let's go. Eric, what do you want to plug it into? Top or bottom? Top, sure. Negative 4 times 7 plus b equals negative 26. This is negative 28 plus b equals negative 26 plus 28. b equals 2. 7 comma 2. Raise your hands if you agree with that answer. Excellent. Good, good, good. Okay, couple little things with elimination that need to be addressed. Elimination has issues as well. And I think you already know what they are. Here comes number 3. If I say 3x minus 2y equals 10 and 4x plus y equals 6, and I told you, look, it is possible. In fact, you better use elimination on this process. The problem is that if I just eliminate downward, I get 16 equals negative y and then 12x. I still have 2 variables and 1 equation. That doesn't help me at all. But does it look like one of them could use just a little bit of a push to get to be eliminatable? Yeah, which one? Amrit.
You multiply the bottom one times 2.
Multiply the bottom one times 2. And now we have a position where we get 8x plus 2y equals 6. The top I'm going to leave the same. 3x minus 2y equals 10. We gave the bottom one a little bit of a push. It can go away now. 11x equals 16. Did I make a mistake somewhere?
You gotta multiply the 6 by 3.
Oh, that's why. Thank you. Thank you. So 11x equals 22. Thank you, Amol. I must have woken up on the wrong side of the bed today because earlier I thought that 4 minus 1 was 4 in my last class. So I'm just kind of not with it. So thank you for bearing with me. Amrit.
How many points would that be off? You have to multiply that.
All I can say is it's a good thing that I'm not taking my own quiz tomorrow. All right? So, anyway, what do you want, Madison? Top or bottom?
Bottom.
Bottom? Sure, we haven't done the bottom ever. 4 times 2 plus y equals 6. This is 8 plus y equals 6. Y equals what? -2. You are done. Okay, next example. Sometimes, well, yeah. Sometimes one of them needs a push, sometimes both of them need a push. But I'll give you guys another one where one of them needs a push. Okay, go and take care of that one on your own, please. You. All right. Let's see. How about Justin? What should I do first? Oh boy. Who knows what the first step in this problem is? Javad.
Multiply the top by 3.
I would say we should multiply the top by 3. That way we can eliminate x, right? That's going to get out of there. We got 11y equals 66 again? Okay. Y equals 6. Okay, now either one of these is going to be okay to choose. So, Jared, which one do you want?
I took the top one.
The top original one? Sure, we can do that. X plus 3 times 6 equals 13. X plus 18 equals 13. X equals -5. Raise your hands if you got -5. 6 is your answer. Good. All right, let's take care of one that's really, really kind of rocky. What number are we on? 6? Okay. Now, there are a number of things we could do here. We could either fraction bust both of them, or we can multiply one of them. Which one do you want to... Kiyomi, what do you want to do? Fraction bust the whole thing, or what? You want to fraction bust the whole thing? Okay, you're going to go the long way. If I fraction bust the whole thing, what am I going to multiply both top and bottom by? 10. So, what am I going to get? 10 here, 10 here, 10 here. Same thing here. So I get 10x, no, just kidding, 4x minus 5y equals 60. That's gone. Now I get 8x plus 15y equals -80. Which one should we eliminate? What do you think? Jonathan, which one do you want to get rid of? X or Y? For real? Y. Y. Get rid of Y. Multiply by 3. That way it can become 15. 12x minus 15y equals 180. That gets out of there. 20x equals 180. So 20x equals 100. X equals what? 5. I'm going to choose one of these ones. I'll pump it into this one here. 4 times 5 minus 5y equals 60. Negative, 5y, we've got a 20 right here, equals 60. Negative 5y equals 40. Y equals -8. Yeah? Okay. Other thing you could have done from the beginning is multiplied the top by 3 only, and then the 3 over 2 y's would have eliminated, and you just multiply by the reciprocal, it would have been fine. Could have done that. That would have been, to me, that would have been faster, but, you know, hey. As long as you get there. All right. Let me give you a couple to do on your own before we wrap it up. Okay, take care of those two, please. Okay, so what do I need to do with number 7 first? Javad, what should I do first? Okay, if I multiply the bottom one by 2, that's going to get me to 2x, and I have a 2x on top minus 3y equals 13. I should probably multiply by something just slightly variant of 2 to be able to make it an eliminating function, to be able to make it an eliminating system. Mr. President, negative 2x. Should be negative 2x plus 2y equals negative 10. And that's going to go away. I've got negative y equals 3, so y equals negative 3. Raise your hands if you got that. Got that? Top one. So I got 2x minus 3 times negative 3 equals 13. 2x plus 9 equals 13. 2x equals 4. X equals 2. X equals 2, y equals negative 3, yes? All right, next one. What method should I probably use for the next one here? Sophia, what method is probably best? I could do that. I could have done that. But what method? Did someone use a different method on number 2? Evan. Substitution. Now, Sophia, totally not wrong, but a little more work. It's got 3x minus 10 plus 4x equals 11. 7x minus 10 equals 11. 7x equals 21. X equals 3. I'm going to plug this into the top equation here. So I'm going to get y equals 5 minus 2 times 3. That's 6. 5 minus 6, y equals negative 1. Raise your hands if you agree with those two answers. Okay, good.